let's talk about L'Hopital's rule. So up until this point, we've investigated limits, such as the limit as x approaches 5 of, say, x minus 5 over x squared minus 25. And the first thing we do when we evaluate a limit is look at what happens when I plug it in. Well, if I plug it in, I'm going to get 0 over 0, which is indeterminate. We don't know what that is. So we said we can use our algebra. We can factor this. That factors into x minus 5, x plus 5. Then we could reduce, and we're left with 1 over x plus 5. Now I can plug it in, and we find out that the limit is 1/10. Now, sometimes we got stuck, and then we used other methods. L'Hopital said, well, if we have this indefinite form, there's another property. And so he found out, discovered, and here. L'Hopital said that if, when you plug it in, you get 0 over 0 or infinity over infinity, then the limit as x approaches some number c of some function divided by another function, that's equal to the limit as x approaches c of the derivative of the top function divided by the derivative of the denominator, the bottom function. Now, you should note, this is not the quotient rule, right? It's the derivative of the top, derivative of the bottom. Completely two different things, not the quotient rule. So, L'Hopital's rule, so if we look at the limit we had before, the limit is x approaches 5 of x minus 5 over x squared minus 25, we get 0 over 0. So then we could apply L'Hopital's rule, which says take the derivative of the top and the bottom and then evaluate the limit. So let's try that. The derivative of x minus 5 is 1. The derivative of the denominator is 2x. Now plug in 5 and you get 1 over 10. Pretty slick, huh? Now, you can look in your book in the back. There's a proof of L'Hopital's rule and where it comes from. It's related to the mean value theorem and why it works. But it's pretty amazing. Now, you need to remember, though, you can only use L'Hopital's rule if your limit, when you plug it in, gives you 0 over 0 or infinity over infinity. Now, let's look at an example where we have infinity over infinity. So, for instance, the limit as x approaches infinity of 5x squared minus 4 over 2x squared, or how about even better, over 3x minus 7. Now there's a lot of ways we can think about this. If we plug in infinity, we're going to have a large number divided by a large number. It's important that you denote kind of the case. Now, L'Hopital's rule says we could take the derivative. So I'm going to do that. I know that we've done this other ways, and you may already know the answer. If I take the derivative of the numerator, I get 10x. Take the derivative of the numerator, we get 3. Now if I plug in infinity, I get infinity divided by a constant. Well, that is a large number. So this limit grows without bound. It does not exist. We had said before, if we're going to infinity, Well, if the numerator is a larger exponent than the denominator, then you know the answer is going to be infinity. That's great. You could also think about it, this is quadratic. It's growing much faster than something linear, so we know it's going to be infinity. So there's multiple ways to get there, but I wanted to illustrate that L'Hopital's rule still works for infinity over infinity. Most of the time, you may just look at it. Now, there's another form. So for AB calculus, this is the only form of L'Hopital's rule that you need to know. For BC calculus, we're going to look at two other forms.